Okay, and welcome back to part 2 of multiplication of polynomials. We're going to start again with the distributive property. And again, a reminder of what the distributive property says. It says A times B plus C is A times B plus A times C. Now remember that also extends if your polynomial is not binomial, in this case B plus C, but it could be a polynomial in which it has 3, 4, 5, however many terms. You're still going to multiply that A by everything that is inside there. So I'm going to go ahead and jump down to a couple of examples here for you. And so again, on number 1 here, if we are doing distributive property, we're going to take a -6 times both of these numbers, which in this case would be a -48v minus 6. Okay, now I've given you just a little bit harder one here because we do need to be able to do distributive property with fractions. And the thing about this one, if you need to come to the side and multiply your fractions, you can do that. The other way you might do that is go ahead and write this out if you can't, but you can also run it through your calculator, not computer, but double negatives here is going to make this positive, and then that's 4/3 times 1/3. So you could write that out if you needed to. Now in this case here, my 3's are going to cancel, and 2 goes into 4 twice. And so this is actually just going to give me 2x, okay? And then in my, on my second one here, that would be, now this one's not going to cancel, so 4 times 1 is 4, 3 times 3 is 9. But be able to do distributive property with both fractions, and then next below is with decimals, also be able to do it with decimals. And so again, we would just need to come in and multiply these out. Let me grab my calculator real quick. And so we would take 1.4 times 1.5, and that is going to give me 2.1 x squared, and that would be negative. And then we've got 1.4 times 0.7, and that is 0.98, and so that would be plus 0.98. So again, you're going to use exactly the same rules. Okay, so that is just your distributive method. And then let's talk about what FOIL is. And guys, FOIL is actually just the distributive property on that. And so remember, FOIL stands for, it's just an acronym so that you can remember what to do. And it stands for, first, outside 2, inside, and last. So let's just go down here to a problem and show you what we mean by that. Now, I'm going to show it to you as FOIL and as distributive property both, just so you see. So distributive property, what it means is to take this x times both of these, okay? So that would be x times the 3x minus 3, and then it also means to take the 1 times both of these. So we could write it as 1 times the 3x minus 3. So that would be, again, your distributive property. And so when you multiply this out, you're going to get 3x squared minus 3x plus 3x minus 3. And then we're going to combine our like terms because we already did addition. In this case, the 3x and the negative 3x are going to cancel, and I'm just left with minus 3. Okay, so that's technically doing the distributive property. Now, if you're doing FOIL, the only thing that is different, let me just rewrite that over here real quick for you, is the acronym is saying take first. That means take these two. So that's x times 3x, which is the 3x squared, which look is that piece right there because that's what I did. And then it means to take the outside 2. So that is the x times the negative 3. Well, guys, that is this piece right here that I just did. And then you're going to take the inside 2. So now I'm doing this piece, and I get the plus 3x. And then I do the last, and there's your minus 3. So again, your FOIL is just doing the distributive property. It's just giving you that acronym so you remember an order, but you don't have to do it that way. Definitely you could write it out. Okay, so that is FOIL. And guys, here's the key to FOIL. It will only work if you're doing a binomial times a binomial on there. But FOIL, or a distributive property, works for everything. Okay, so that's kind of the difference in the two. That FOIL acronym is only for a binomial times a binomial. Okay, the next is to talk real quick about the box method. And again, the box method is basically, another word for it is called the area model. You might have heard that before, because what you're doing is no matter how big your box is, you are taking your length times your width. Okay, that's all you're doing. So you're looking at this box in terms of length and width, and you're just doing area. So remember, area is just length times width, and that's all you're doing. So that's why the box method or the area model. Okay, now I definitely think that works great when you have anything above a binomial times a binomial, although I think the binomial times binomial is also, could definitely be done as a box. But when I get bigger, I think it does help in the organization. So I'm just going to run this a box method. And it doesn't matter which way you write. In other words, I'm going to put my 2b and my plus 1 here, but I could have turned my box. This is 2b squared plus b and plus 3. Do put your signs in front of your numbers or variables or whatever it happens to be. So again, I'm doing the box. Let me get a light color here. And so what I'm basically doing is finding the area of this box. And so that would be length times width, which would be 2b times 2b squared, which would be 4b cubed. Okay, and then I'm just going to continue that. So my next one, again, I'm now finding the area of this box. Okay, so that's 2b times b. That's why we put those letters above. So that's 2b squared. And then my next one would be finding the area of my third box. And that would be 3 times 2b, which would be 6b. Okay, and then again, we're going to continue that same thing with the bottom row. And I've got 2b squared. So I'm just timesing it by 1, b, and plus the 3. Now, past that, if your polynomials are in descending order and you're not missing any terms, then what happens here, which is very nice, is that your diagonals are your like terms. Okay, which makes it then very easy to add. So I've got 4b cubed plus 4b squared plus 7b plus 3. Very easy to organize, okay? There are multiple ways to multiply polynomials, guys. Box method, I think, is just a very easy way to organize your work. It also helps for some of you. I'll show you how to factor using the box method, and that definitely helps out. So again, this one is just a bigger box. I now have a 3 by 3. Okay, and again, it doesn't matter where you put things, so I'm going to go ahead and do like I did last time. I'm going to put my first one here and my second one here. And again, I'm just going to start finding the area of each of my boxes. So I'm going to start with my first box. And just be very careful with your signs. So in this case, I've got a negative times a negative, which makes it positive 3, and then x2, and x2 is x4. Okay, and then just continue on. So I'm going to get 3x cubed negative 6x squared. Okay, then I'm going to go down to my next row, start off with those. And so negative 2 now times the negative. Okay, so I'm now doing these two. And so that is 2x3. Continue across, and that's going to give me 2x, and then a negative 4. Negative 2, or 2x squared, and then a negative 4x. And then I'm going to continue on to the bottom row and do the same thing. So I'm going to get 3x squared, 3x minus 6. And again, now my diagonals should just be able to be added together. Okay, and so I'm going to get 3x to the 4th plus 5x cubed minus x squared minus x minus 6. Okay, so again, that is your multiplication of polynomials.